The class is all about data ingestion, and I will show you something very new as well, which will be very much helpful to you. The organization is also adopting these two things. So let me just give you a brief overview of what we are going to cover. In the data ingestion, I have talked about mainly two tools which is coming along with Hadoop, and we have done that very well. One is Scoop, and yet to do is Flume, right? And in parallel, I have showed you how ingestion can work using Presto. The easiest, fastest, no doubt, is Presto. Scoop, it is for bidirectional data transfer. You have got import as well as export. You can only bring the data from RDBMS to your HDFS or Hive, and you can take the data back from HDFS to RDBMS. You cannot export from Hive. Please remember that. You cannot export using Scoop from Hive. What you can do is only you can find out by describe formatted where is the file of Hive, and then that file has to be exported. They told you the problem when you are exporting it. What is the problem? That new line character, that /u001, that character. So that character you have to give as in lines terminated by and fields terminated by, then only it will work. Otherwise, export failed error. Do you remember? Export failed error will be coming, so it will not be working at all. That's what we have seen, right? So today we are going to see the next important one, Flume. This is not used in the companies where Cloudera is not the platform, because Flume or Flume NG, sometimes it's called as Flume NG, which is Flume next generation, that is by Cloudera. Okay, so Hortonworks sometimes say we don't support it, but it is very useful utility. As you can see, you will be seeing it, and it can take the data not bidirectional, so it is not bidirectional, and it can read mainly from logs, files, etc. And from where it is reading is called a source, and where it is landing the data is called a sink. And a source and a sink has to be connected by something called a channel. That's the fundamental idea of Flume. Source, from where you are bringing the data. It can be your log files, etc., etc. Channel, it can be memory, it can be any kind of connections, TCP/IP, etc., etc. That is channel. Sink is where you want to land. A practical application that I did around 2014, because in Citibank we were using Cloudera. So in Citi, there is an application. This application is called Eclipse. So if you go to any branch in Citibank, when you give your card, they will log into this Eclipse application. And the moment they swipe the card in that machine, it will take all your data and it will show you your customer 360 screen. And Eclipse is a combination of many modules. One module is called CRM, another module is called fund transfer, another module is called statements, another module is called account transfer. Like that, there are 11 modules, and these 11 modules are being developed by 11 different teams across the globe. Okay, some teams are working in Singapore, some teams are in India, like that. So each module is a WAR file. If you know web applications, WAR is web archive, right? So each module is a WAR file, and everybody has got their own logs. So let's assume that I'm supporting Eclipse from US, and some problem happened in Eclipse, right? I don't know that which module caused that particular problem, where to look, how many logs are there, which team has developed. Big problem to aggregate the information. So basically what we will do, we will start troubleshooting, and it takes about 1 to 2 months of time in order to go through everything and then finally come up with a particular solution. So wherever multiple modules are there in a big web application, this is a big challenge. How will you find out the corresponding logs and pinpoint the team that, hey, this is the problem in fund transfer? Yesterday you put a jar file or you changed something, because of that the entire application is affecting. If you want to tell that, you should be knowing about that application very well, and you don't know it because it is developed by other team. What you can do is you can install a Flume ng in each and every log destination, that is the source, and tell Flume to put everything into HDFS with a comma separated value file and expose that into Hive. And now you create your BERT report from Hive, which will aggregate the complete logs at one single place, and then you can search for exceptions very fast. And you will be able to troubleshoot what exactly is the problem. Got it? So that is one of the applications of where Flume can be. Okay. There is another tool, and you might have heard about this tool, very costly, but we are using it. It's called a Splunk. What is Splunk? Splunk is a log aggregation tool that is used mainly in big organizations. What it will do is, it will collect the logs of Unix, it will collect the logs of your web application, it will collect the logs of your data quality, all the things it will collect, and then it will create a complete flow of what exactly is happening at which particular point. It is very costly and tedious as well. And to overcome this, most of the things that Splunk is doing, you can do with Flume, okay, because it is also reading the logs. Okay, so what I want you to do is, first is we are going to use Flume in the basic way, and after we execute Flume and understand what Flume is, we are going to install Kafka. Kafka is a queue or a messaging system, which is going to be one of the very important component for you in your future. And we are going to read from Kafka and we are going to put it into HDFS, right? And depending upon where we stand, I will show you some advanced concepts where we can put all those things into Elasticsearch, and then we can search as well. Elasticsearch is a search tool. I will explain you what it is later. Okay, so what we are going to do is open your virtual machine, and in the virtual machine, please go to foroursun.com/passion and find out a file called Flume November 9 2017.tar. Please don't take flumeconf.tar.alt. There is a file here which is alt, which is ending at alt. Don't take that one, but take the other one, Flume November 9 2017.tar. Okay, and then click on save file. All right, and what you need to do is just move that file from the downloads directory to your current directory, and then execute the tar xvf command in order to extract it, right? All as usual. We are extracting all that one, and you can see that it will create a directory called Flume in your home directory, which is what I want. So if you look at that cd Flume, all the things will be there inside a conf directory. This is the most important thing, that here all the work will start by writing a conf file. So to work with the Flume, to work with Scoop, what do you need? Scoop, import, minus connect, right? You know the command for Scoop. Whereas for Flume, you need a configuration file. And can you guess what you will do in that configuration file? In the configuration file, look at this. You will specify source, channel, and sync. That's all. So, without the configuration file, you will not be able to work on Flume. I have given you many examples here. I'm not going through everything. For example, twitter.conf is a beautiful example where the Flume source is Twitter. It will connect to Twitter and it will fetch the data and it will write it. And you remember that we connected to Twitter once by using my key and my secret key and password, right? I'm using the same thing and we are connecting it using Flume. So I'll show you how you are going to use all these things in a while, okay? Now, let us take the first one, which is example.conf, okay? And this is again, if you are writing 175 examination, very, very important question is, they will give you what is the source, what is the channel, what is the sink, and one more thing, what is the agent? An agent is an extra thing that you need other than the source, channel, and sink. And agent is the name of your Flume configuration that you are going to do on your application. For example, let us assume that there are two logs happening onto the same computer. So in this computer, two logs are happening. So one log will be read by one Flume configuration, another log will be read by, let us say, another Flume configuration. How will you distinguish between these two Flume applications? By agent name. It is like human names, okay? So agent name will have source, sink, and channel defined. So they will be, or in the examination, they will tell you your agent name is XYZ. Immediately, you should make sure the first word in that entire configuration file should be the name of the agent. They will be putting a dash. Please fill in the blanks. They will not tell you to write everything because in the examination, you may get about 5 minutes for answering this question. They will be putting some dashes at some places. They will give you the skeleton. Understand? So, the first word in your entire file is going to be the agent name. So, from here, you can easily say that my agent name is A1. Okay? A1. So, in the question, if suppose they are telling create an agent called Cloudera, that means every line will start with Cloudera dot Cloudera dot Cloudera dot. They will intentionally put this particular word as dash so that you have to fill it out. Next, 3 code letters I am assigning for the source, sink, and channel. My source is called R1, my sink is called K1, and my channel is called C1. And then you are going to define what is R1, what is K1, and what is C1. And finally, one line will be there where you will tell that how the source and sink are connected by which channel. So please look at this. What is my channel? My channel is memory. And what is the capacity? 1000 strings I can take. Transaction capacity at a time, 100 messages can be written. That's about my channel, this pipe. So, I will use memory whenever the data is coming from source, and then I am going to put it into a sink. What is my source? My source is, I will show you what does that mean, is an application called Netcat. And my sink is logger. In Flume, if you put logger, the meaning is don't write to any database or anything, just to print it in the output screen. That is the meaning of using a logger. This is one of the very famous examples of Flume. Okay, so if you can see this example working very well, if suppose you are going to Flume documentation, just type like scoop documentation. I told you this documentation also will be open or during your exam, but you won't get time. So you can just go to Apache Flume and you can look at how to, quick start guide will be there. Documentation, Flume user guide. And you will see all the diagrams that I have mentioned, the source, the channel, the sink, and you can have the source and you will be finally writing the data, right? It is not database. See, none of them are databases. And if you are coming down, you will see a very simple example of how to use this particular Flume, and I will just make it bigger. So see here. This is what I have copied in that example.conf. Okay, because this is called the hello world of Flume, right? And what we are going to do is we are going to start this particular Flume and then we are going to execute it. Okay. Now, what you need to do is there are some things to be happening here. So go back to your console and type a command called telnet. If it is the first time, you are going to get an error telling that command not found. Expected. Okay. And what I want you to do is type sudo yum install telnet. Sudo yum install telnet and then press enter. And if there is a question coming in Y or N, just type Y because it is now asking your permission in order to make sure that can it be updated or not. So it's asking, is this okay? So lowercase y, press enter. I will show you the command. Please look here. Sudo yum install telnet. Sudo yum install telnet. And once that is installed, you can start it. But before I am starting, what I am going to do is, open another command prompt. Let us start Flume here. And please do copy the command Flume ng and agent. You have to give the agent name and you have to give the configuration file. Okay. So let me type in one by one all the complete commands, making sure that there are no mistakes. After I type, you type it. So Flume ng, as I mentioned to you, right? And then agent minus name. And what is the name of the, what is the name of your agent? A1, right? That's what we have put it in the configuration file. That should match the first word in the configuration file, right? And then there is -conf. What is that? Oh, sorry, agent. -conf. I think that is the
configuration file example.
No, it is a configuration directory. So you give the directory name there for -conf. The directory is home / cloudera / flume / conf. And then one more is there, which is conf-file. Okay, you have to give the directory name as well as the file name because directory may contain many files. So the file name is example.conf. Sorry, example.conf. And where is that example.conf? Home / cloudera / flume / conf / example.conf. That's the complete command. Right? Before typing enter, go back and let us look at that vi example.conf. I am telling that my source is a netcat application running on port 44444. You will simulate this particular application by typing telnet. That's why we have installed a telnet. Type localhost 44444. Wait a minute. What is the command? Yeah. The reason is we didn't start that Flume. After we start the Flume, we have to do that. So press enter on this command and wait till you are getting a message created server socket. See, once that is created, then only you will be able to listen to that. Now it is telling that, okay, I'm listening to that. Come back to our other window where you got error earlier. Here. And type telnet localhost 4444 in the other window. See, now you are not getting the connection refused. Why? Because the Flume agent has started that process. The other command? The first line. Flume ng agent minus name, the name of the agent. The name of the agent is A1 because that is what we have mentioned, and then you have two parameters. One is minus conf, which is telling you where is your configuration directory. Another is minus conf file, which is telling you what is your actual file. That's all. One is directory and one is a file. Done. And now what I want you to do is just type a hello world. Okay, keep the screen like this on the right hand side. And on the left hand side, just type hello world and see what is happening on the right hand side. That's what the Flume is all about. So Flume is taking the data from this particular process, using the memory channel, it is printing that particular data. These are the hexadecimal numbers. Always Flume will give the logger by default, will give you that other numbers as well, headers, body, etc. It's actually a JSON file.
Select localhost.
Space 4444 provided, you have started the other one. Enter. 5 fours. Yes, now you type hello and then you should see other window displaying that particular data. Right? Clear? Close the Flume agent and close this one as well, right? It will be automatically closed. Why? Because the process is stopped. Next one is I want to put the data from that same process into HDFS. So look at the next example, which is hdfsexample.conf. No change at all. Look at that. Name is A1 still. But if you come little bit down, you will see the main change there. Earlier, it was logger, but now you are telling that it is HDFS.
So, if you wanted to use multiple agents, like you have to create multiple agents here. If you want to maintain the old one as well as the new one, then you create a new agent.
Maintain the old one as well as the new one?
Yeah.
Two agents you have to start.
Yeah.
Two windows, two agents you have to start. That is the purpose of agent.
So instead of
So give a different name to that particular agent. That's all.
How do we do this in large scale? Like in enterprise wise?
It is not. That is the drawback because it is not scalable. Right. Okay, it's always for one system. Right. Okay, and now look at some more important thing. The moment you wrote HDFS, that is not over. Which directory in HDFS, correct? You have to tell which directory, what is the capacity, and what is the prefix. These are all some of the things for you that you can create your own naming convention if you want. A good example for you is, suppose the data quality or data lineage tool has been put into production and you want to find out how many users are using it, and the logs are written by, let's say, Informatica at one particular place. Create a Flume agent there and then route all the logs to your Hive and then create a report. Right? So, HDFS example, let us execute this one. Exactly the same steps. So what I'm going to do is, this is HDFS example and it uses netcat again. So I'm going to the other window, right? And execute the same command, but this time don't give that example.conf, but instead you give HDFS example.conf. Very small change. Only the last parameter is getting changed because now we are going to read it. But agent name, do I need to change the agent name? No. Why? Because agent name is A1 still. So for Verma, it will be changed into a different agent. So you can have multiple agents listening to a same source.
How did you get the thumb back?
Huh? Control C. Oh. Control C, Control X, all this will work to come out. All right. So HDFS example.conf, press enter and go back here. Again, telnet localhost 4040. After you see the message, it is listening to the process. On the Flume, you should see the message. All right. And now go on typing something, because we are, now nothing will come on the logger because we changed the logger. Logger will show you the output on the output screen, but now there is no logger. So just type something. And you will see something is happening there. And you know all that words, what is meant by bucket writer and all those kind of things. Sequence file. It is creating. And you can see that it is waiting now. Again, if you go back, type some more strings on this. Again, you will see on the right hand side after some time, it will move. That means a kind of polling. And it is going to, see, it will be going on moving the data. And once everything is completed, just close this one. Clear? Hadoop fs minus ls. What was the directory name? /user /cloudera/Flume. Why are you seeing the file name as netcat dot? Because we used the prefix. What was the prefix we used? Netcat. Look at the configuration, open the configuration and see. In the configuration, we have used the prefix as netcat. That's why you are seeing it. Okay. If you want to see it again, please look at the configuration file, vi hdfs example.configuration. Look at this. The prefix was netcat. That's the reason why you got netcat as the file name. So if many files are coming to your HDFS and you want to expose only certain files to your Hive table, that's the trick. So if data quality, data lineage, then you create a prefix data lineage dot. You will know, even if many people are writing, what are the files that are designated for you. And now the surprising thing is going to happen here. Hadoop fs minus cat /user /cloudera. So whatever I typed is there on the left hand side. I should be able to see that, right? User /cloudera /netcat star. Unfortunately, netcat dot star. Oh yeah, user /cloudera /Flume. Flume / let us write this one completely. What happened? It's encrypted. Some data is there, something is there, but it is completely an encrypted data. The reason is that you might have seen the output that you got from Flume. It uses a sequence file by default whenever you are not specifying how you need to write it. That's the reason why this example is not that helpful. How will you make it readable? This is not readable, correct? So, what you will do is, I am going to run another example, but before running it, let me show you VI readable configuration, and I will change some things on the bottom. Is that you must specify file type as data stream. That's the trick. If you don't write that line, it will be using sequence file. So make sure, why two examples were given is, make sure that whenever you are creating an HDFS sync, you should write that data stream, otherwise the sequence will be htstat. And some more things that you can do here is that you can give the directory name and you can tell it is memory and you can give the prefix, all that other things are there. And you can also specify a roll interval, which means that it will create files one by one, 1, 2, 3, 4, 5 after every 120 seconds. So if you run that one, let's say, and go to the other window, and this time run the same example, but this time give readable HDFS example as your this thing, and wait for the server socket listening. Yes, it is listening. And now type the telnet here, and you just give hello world, again hello world, and then let's say goodbye world, right? And give some time until it is writing it, and then maybe you can type some more to flush it completely, and just give some time until the logs are moving. Why? Because it is not very instantaneously getting invoked. There is some time that is being used, and now you can see that there is a serializer which is not sequence file, which is a text-based serializer which is being used in the complete application. So Control C now, and clear, and then Hadoop FS minus ls. Oh, we didn't delete the directory. But there should be something else that is getting created. Let's try. Hadoop FS minus ls, right? Hadoop FS minus ls Flume. Maybe latest timestamp. See, another file created, which was the earlier one. Yeah, this is the latest one. So what we will do, I am going to copy this one. Right click, copy, Hadoop FS minus cat, and then paste that particular file, and then command A, oh sorry, Control A or command Control A, Hadoop. Now you will see without a sequence file, the complete files are being written. Okay, and the moment you want to come to HDFS, now you know what to do for exposing it to Hive. Load data in path and load that particular file onto Hive, then the data is available on Hive. Very useful. Right? Another interesting thing is,
One question.
yeah, yes.
So you said this is not scalable, right? So can we write a cron job to invoke Flume and implement it and run multiple threads?
No, there is a better approach. I'll tell you that. Okay, so let's just wait. All right, so now there is one more thing that you can do is, till now we have used what? What is our source? The telnet, right? That is just an example. That's not a good one. I want real life logs that to be pushed into, let's say, HDFS. For that, first let us do one thing. Hadoop fs minus rmr, that directory, user slash cloudera slash flume. Clean it out.
So, quick question, Ravi, how to kill the Flume process?
Control C.
No, it's running in my backend, I think. So, even
No,
though
that takes time. I have that issue. It takes time.
It will go away.
I closed it when I tried to rerun the command, Flume command. It's saying already unable to start.
So ps minus ax, find the process, kill minus 9 is the command. Kill minus 9 that process. You can see that Flume process will be running by writing a sudo jps. Type a sudo jps. You should see your Flume is running with a PID.
Yeah, I typed PID, but
Not PID, just type in PID, nothing will be coming.
I'm trying to identify the process, which process it is. I have like.
What are you saying? I'm telling you that there is something which will tell you. Sudo jps Java processes. And then you are not seeing Flume means it's not running. Okay. All right. So open that real logs.config and Cloudera has given you an excellent facility there. So please read whatever notes I have written. Anywhere in the virtual machine, if you type start underscore logs, don't do it now. What will happen? In the Cloudera virtual machine, they have given you a beautiful program. That program will automatically start generating logs. Where? In this particular place. It will simulate Apache logs. You know what is Apache? Apache HTTP is the web server. So whenever somebody is accessing through HTTP to Apache, it will write access log, error log, etc., etc. Out of that, they have simulated this access log. I am going to show you that. Okay. Please don't do anything now. I will tell you later. When I type start logs, okay, start logs I am not copying. I am going to copy this one. Okay, access log. This is the location, right? Copy. And what I am going to do, just for showing you, in this particular one, I am going to write tail minus f access log. Okay. See, it's not moving at all. Safari 537, it is already existing. Now I am going to write here start logs. Understand? Nice program. Okay, so it will give you that simulation of logs, like actual users are logged. This is what will happen in an enterprise. The logs will be happening, right? So I'm going to close this one, and I'm going to close this one. Right? And now let us look at the real logs.config. Now my source is tail minus f, that particular log file. Just now I did the tail minus f. What tail minus f will tell you? All the new additions of the logs it will tell you. It will be taken and I am going to write that into HDFS. But this time I am making it very, very flexible. I want a file premix by telling that every day what is the log. So how will you give the day? There is a use local timestamp equal to true. When you write like this, you can give year, month and date so that it will be creating every day automatically the log files. This is how the production usage of Flume is done. Normally Apache logs will be in 1 or 2 machines. So you will be running the Flume agent in those 2 machines. Right? So execute this one. It's very interesting. So what we will do is come out and I am going to write start underscore logs. Okay? Start underscore logs in one command window. And in the other command window, I am going here and let us write exactly the same command inside the conf type reallogs.conf file, so that now it is going to read the logs and going to put it in the HDFS. And you see here now, so many things will happen here. Why? Because the logs are already written in the background in that particular file, and you are doing the tail minus f. See, it started reading it. And can you guess what is the channel that I used in this example? Is it memory or is it something else? Channel, the pipe. I used a file. Please look at the configuration. So you can see that the channel is a file. It will be writing the data to intermediate file, and from the file it will be reading back. All right. After some time, please make sure that you are coming back to the other window and don't leave it running. Stop _ logs. And close this one. And let us look at that file. What is the file name? vi reallogs.conf. Okay, it is inside user _ clouder _ flume with the date stamp. So, copy. Hadoop fs -ls. Right click, paste. You should see the timestamp now. Look at that, 190305. And now if you look inside, oh sorry, there is a wrong. What is that? 19-03-. Look at that. Inside that it created that particular file with that Flume, this one. Why? All that configurations, if you look at that vi reallogs.configuration, I have told that in this directory you write it and every file should be prefixed with the word Flume and the date timestamp. That's what you are seeing here. Clear? In this way you can control the complete data. All right. Come back. Clear? vi. There is another one. For that we have to do something, which is vi oltp.conf. Oh, so not oltp. realtime.conf. This is a nice example. What we are going to do is, from Flume, we are putting the data into Kafka. So we'll take this opportunity to learn what is Kafka. Source, channel, sync, and you are telling that you are having a Kafka source this time. This is one method, Verma, to make it scalable, because Kafka is highly scalable. So if you have multiple agents in multiple machines and you put everything into a Kafka queue which is centralized, that is one of the ideas for making Flume scalable. Because Kafka is an amazing technology, and just look at a message. You just type Twitter 1 trillion Kafka and press enter. Oh my God, it is already crossed 5 billion sessions a day. 5 billion sessions a day. In this world, there is nothing bigger than this. And they did it with, I think, about 15 or 20 Kafka topics. The simplest hardware, the best possible way, right? If you divide that 5 billion for 24 hours, how many seconds you get? You will still get about 500,000 or 1 million, near to 1 million per second. And nobody can have that much volume, right? So that is the power of Kafka. And that's why Kafka is very widely used. Our guys Amazon, I think they didn't like Kafka. That's why they created an equivalent of Kafka. What is it called? Whenever you heard this word, remember. It's called Kinesis. Kinesis is the equivalent of Kafka provided by Amazon. Okay, but most of the widely used applications will be using Kafka. So event bus, asynchronous subscription, all these kind of applications are going to be implemented by using Kafka. Right? Now, to know what Kafka is all about, please go to forourson.com/passion and the first file, advanced ingestion tools to acquire data streams using Flume and Kafka. Please take that one. You will get an overview of what I talked just now, which is talking about Flume, where source, channel and there. And when you are going down, if you have underestimated Flume, please look at that. How many types of sources, how many types of channels, and how many types of syncs are already being provided by Flume. It is very, very powerful. The only thing is that Hortonworks really does not support that one, but it is very, very powerful. Now, this is what we will be using, Kafka sync, where I will take from the Flume and I will put the data into Kafka. Now, if you come down, we are not putting into Kafka. I think we are using the Kafka source. Kafka source, this one, left hand side. All right. Now, if you are coming down, I have given all the examples that I have explained to you today. So this document will serve the purpose of the video that we have taken today. Every step with screenshot is there. First document in forourson.com/passion. Advanced ingestion, right? So this is the situation when the gentleman named J. Krups joined LinkedIn some time back. And this is exactly the same situation in our companies also. Every department, every database, every application sends data to every other department, every other application. Nobody knows what is going on, where what is going on, etc., etc. How can we solve that? And he solved that particular problem by creating something called unified log, where every application is going to write and every other application is going to subscribe. That unified log is what in the world called as IBM MQ, publish subscribe model, Kafka, event bus, enterprise service bus, enterprise data bus, TIPCO, all same. But LinkedIn has done fantastically brilliant idea of using very cheap commodity hardware to achieve this particular result. If you are going for IBM MQ to handle that 5 billion or trillion messages per day, the cost will be minimum some 20 to 30 million. Whereas if you are using Kafka, that may be completed maybe less than in 1 million. See the difference. Exactly the same resilience, faster response, no failures at all. That's what Kafka is all about, and it is surprisingly nice article is written by this great guy, J. Krups. And what I want you to do is, please read that article. How will you read that article? Everything that you need to know about logs by J. Krups. This is what you have to type. Everything that you need to know about logs, J. Krups. JAYKREPS. And press enter. It should be the first hit. Look at that. This is the article. The log, what every software should know about real time. And as you can see, the author is Jacobs, and he is the creator of Kafka. And please read that 14-15 page document in order to know in and out of Kafka and how the problem is resolved. And you will see the diagram that I have just described to you is copied from this particular article. Okay, so if you come down, you will see it somewhere in that article it is written. Okay, so J. Krebs is the inventor, and why he used the word Kafka? Kafka is the name of a great English author, and the author always writes, and Kafka also writes the logs. That's the reason why he called it with a author name, unlike other technologies. Very less in the technology computer science world. Author names are the product names, so only one is Kafka. Franz Kafka is the name of the author. He's a great English writer, so he used that name because it's writing logs. Okay. Now coming to the internals of Kafka. Whenever you are putting a message to Kafka, assume that this is your visual representation of Kafka. It goes to a topic. This is your topic. Tell me, when we wrote Twinkle Twinkle Little Star, the first few classes, you all had that yellow paper, and I told that it will be divided into blocks, and each guy is going to get 128 MB block, correct? He did exactly the same thing. The topic is divided into brokers. Brokers are nothing but like your HDFS nodes, multiple machines. And whatever data you are writing is duplicated like leader, follower, etc., etc. And whenever there is a failure, it has the ability to read from the other topic, other broker, and it can process it faster. So exactly a similar concept like Hadoop implemented by using the word topic and brokers. Brokers are like you, nodes. So when I give you a data, say, take it to your Kafka, what you are doing is, you will take the data, you will create the duplicates. Somebody like name node knows where the duplicates are there. If this guy is failing, then the other duplicate node is going to give me the data. So never the data is lost. That's what is being described in the other PDF document that you have seen. And if you come down, you will see how the Kafka cluster will look like. There are multiple brokers. Now, remember, once I told you the most beautifully written stablest code in the entire Hadoop ecosystem is what? Zookeeper. Why? It does the coordination for your Hadoop nodes, name nodes, Spark, HBase. The coordination between different nodes is excellently handled by Zookeeper. Similarly, when there are multiple machines taking the data from me, there should be some coordination needed between the nodes. That is again handled by Zookeeper. So to work with Kafka, the most important thing that you need is a Zookeeper. Fortunately, Cloudera virtual machine already has got a Zookeeper. Zookeeper always runs on port 2181 by default. How will you know? Let me introduce you a nice idea in Telnet which most of the people do not know. So, just type Telnet localhost 2181. What is 2181? If Zookeeper is running, that is Zookeeper port. But if you press enter, it will tell you like this. Just now you have seen it when we were executing the other program. Type a command here, and the name of the command is stats. ST8, very nice command, very good utility. When you press enter, the telnet will come out, but something it will do. What it did? It told you when you typed that stats, what is being executed in that particular port 2181. And if you get this status, that means the Zookeeper is running. For any port, you can type that command, and then you can type stats to know what is running in that particular port. So zookeeper is running. What's the next? We have to install Kafka. So what I'm going to do is clear cd. Let's come back to this conf later. I'm going to go to Kafka downloads in the virtual machine. So go to the browser. Please look if you are not able to execute it fast. Kafka downloads, and it is nice if you are taking the Kafka 2.11 or 2.11. Yeah, 2.11 is there available. Oh, that is the latest. Yeah, Kafka 2.11, 2.10 is there. So I'm going to take this one and I'm going to click on that and click on that. Kafka 2.11 and click on OK. So it is copied into, see how lightweight it is. It is copied into my downloads folder. Now I am coming back here. Move from the downloads that Kafka file and moving to the dot and then write tar xvzf because there is a z in the file name and then clear. You have got the Kafka directory. As you can see, I am going to change that Kafka directory name so that I can access it very faster to Kafka 2.11 so that it is very fast for me to type. Now what I want you to do is go to the browser and go to foroursun.com/passion. And download a file which you will see Presto, Elasticsearch, Kibana, logstash.tar and press enter. The name of the file is Presto, Elasticsearch ES, Kibana, logstash.tar. Everything that you need to know in the world. Save it. What I'm going to do, I'm going to create another command prompt there and I'm going to move that file from the downloads directory. It starts with the Presto and then put dot and then tar, then that Presto, that particular file, Presto ES, that particular file, tar xvf, sorry. It will create a directory called a search, as you can see. And if you do ls, I have given you commands.txt, vi commands.txt, which will teach you the basic commands that is to be used for creating a topic. So what I'm going to do is, I'm going to create a topic. But before you are creating a topic, you have to start the Kafka server. And that command is not there inside this. So I'm going to this Kafka. And I'm going to type bin slash Kafka start. No, Kafka server start.sh config slash server.properties. The moment you see this particular error, unsupported version 52.0, you are running on Java 7. And already in Bibin's machine and on all of your machine, I have told you how to set Java JDK 1.8. We should have the directory JDK 1.8 somewhere. I think in the MongoDB directory, correct. JDK 1.8. Export Java underscore home equal to slash home slash Cloudera slash JDK Oh, sorry, MongoDB. Java home is exported. Export path equal to dollar Java underscore home slash, put a tab to make sure that it is working well. Yes, it is working. Bin colon dollar path. Clear. Echo dollar Java underscore home. Everything you know. And now go to Kafka, because I set JDK 1.8 on this particular window. So now CD Kafka, CD Kafka 211, and now use the arrow key where you typed the previous command. You should not be getting any errors now. Beautiful. Kafka server started. Once the Kafka server is started, unfortunately I have to repeat all these things again. So I am going to open another window because we have to set the Java home again. Echo, sorry, not echo. Export Java underscore home equal to slash home slash Cloudera, no need, slash MongoDB slash JDK 1.8.0. Export path equal to dollar Java underscore home slash tab it is working. Bin colon dollar path and Java minus version. You should get what? 1.8. And once you set this particular one, go to Kafka 211, and now we are going to create a topic. And the name of the topic you should remember is called realtime.test. How will you do that? Kafka is giving you a nice command. Control C, copy, come here and go to the CD Kafka 11 where the JDK is JDK is 1.8, and it will tell you realtime.test created the topic. Now you, in the memory, you created the topic. Replication factor is a parameter that you are going to give 1, which means that there is only one node. If there are 10 nodes, replication factor will be 10 and your data will never be lost. So you created a topic. What is the next step that you are going to do? I am going to put a message to this particular topic. How will I put a message? Console producer is a program that is given by Kafka to test whether your Kafka is running or not. Right click, copy, come here. My real-time test is created. Right click, paste. Hello, world, goodbye, world. Come back to another window. Unfortunately, again, what you need to do? Export Java underscore home equal to slash home slash Cloudera slash MongoDB slash JDK1 dash. Export path equal to dollar Java underscore home slash bin. It's working. Colon dollar path. CD Kafka 211. And now what you are going to do? Producer is producing the messages. What do you need to do now? You have to tell, okay, I am a consumer and I want to read all the messages from the beginning. As you can see, the last parameter. Right click, paste. And I am going to run it here. Oh, sorry. This is my command window. Here is where we set the Java, right? Something is cool. Oh, this is producer. Sorry. It should not be producer. It should be consumer. So I have to copy the consumer command. Where is the consumer command? Yeah, this one. Right click, copy, and come back to here and then paste this one. Ha. And now see the fun. I am going to start typing it on the other window where my producer is still running. I did not close my producer, right? And this is the Kafka server. Don't get confused. So one is the Kafka consumer and another is the Kafka. This is the Kafka producer. And this is your Kafka consumer. Let's move it to the right side. Right? And if suppose we are typing, how will I show you both? Okay. Right. Okay. So now I'm going to write here, hi. Yeah. Passion. This is not like memory channel, Flume and all this. This is highly scalable. It uses NIO, Java NIO, which is a new kind of methodology to deal with the socket level reads from the files. It is highly scalable than the normal methods. Now you created the Kafka queue and the queue is containing the data. See what I'm going to do. I'm going to close the consumer. Right? Clear. And I'm going to go to our Flume directory and I'm going to go to the conf and I'm going to write vi realtime.conf and I'm going to tell what is my zookeeper address, and please look, agent name is Passion in this case, first word, and this is coming from my computer, so I'm going to change it. We are running in the local machine, so localhost and realtime.test, and my bootstrap server is nothing but localhost. And I'm going to read that topic and I'm going to put it into the HDFS as you can see. Okay. So let's copy that realtime.test and the channel 1 is getting created and it is data stream. Everything is fine. Looks fine. Source 1, channel 1 and realtime.test is the topic name. You have to be very careful about 3 parameters. What is the topic name? What is the zookeeper address? And what is this particular address? Alright, realtime.test is now containing that particular one. And what is the configuration file? Realtime.conf is the configuration file. And what is the command? Do we have that particular command? Oh, I don't think so. Anyway, right. What is the command? Flume ng agent minus name. What is the name? Passion minus conf. Minus conf, and what is the name of the configuration directory here? Okay, /home /cloudera /flume/conf. That is a directory name. Minus conf dash file. This time we are going to give /home /cloudera /passion. No, flume. No, yeah, flume /conf /realtime.conf. And press enter. It should read Kafka source and it should start. Yeah, beautiful. It is listening to the realtime.test and it now started reading the data. And at this particular time, we will go to the producer and we are going to write hi, again, hello, something. And the bucket writer is active. And it is there in mine /Kafka/realtime.test. That is the name of the directory. Okay. Realtime.test, Control C. And right click, copy. And I will close this one. Hadoop fs -ls. Right click, paste. And then let's see whether something is there. You have got some data. And again, I used the timestamp method 19-03-05. You have got the data and we used Flume data as this particular value. So let us copy this particular thing, right? Completely. Right click, copy, and then Hadoop fs minus cat and then right click and paste. We use the data stream, so it should not be sequence file. So you got it. So from Kafka, now you use the Flume. This is the most advanced thing that you can do in Flume. You got it, and now you wrote it into HDFS. So any event bus, any event log, disco, Tusco, anything, whatever is coming in, just take it and put it into Hive or put it into this one and apply your MapReduce, whatever analytics that you want, whatever machine learning that you want, everything can be applied. Correct?
So the Kafka, the messages, like how long do you say?
Which one?
In the topic.
Huh?
How long do
There is a TTL parameter, time to live. You can tell that when you want that particular method to be live. And there is another also option available that exactly once read mechanism where after you read it will be automatically deleted.
Okay, so that's what happened here. Like
Absolutely, the previous ones, correct, right? It was using that timestamp mechanism, right? So now that Kafka is also there, let me show you some more things, okay? Because now it is the world of full innovations. CD, clear. I am going to go to, yes, where is it? Where did we install? Yes. CD Presto server. ls. And what is our Java version? Did we change it? Yes, 1.8. What I am going to do in the etc directory now, in the catalog directory, I am going to create a new property file called kafka.properties. And I am going to write 3 values there. To find out what are the values, just to go to Kafka connector Presto. And let us copy 3 values, 3 or 4 values. I am copying that, whatever is there in that under step 3. Don't copy some other section and tell that I am not getting. Ashu, for you. Presto, you copied something else last time. Okay, A, Control V, and just paste it. Connector name is Kafka and localhost. But my table name, now I want to read it as a table. See the magic. This is the real, fun. I am going to read my topic as a table. What is my topic name? Realtime.test. Hide internal columns. False. Kafka, realtime.test. False. Localhost 9092. I think so. Right? Clear? cd.ls. cd.ls. bin / launcher. Run. Wait till server started message is coming in.
this is the reconciliation tool, right? Just to compare.
Anything that that's why I told you this, because you told that you are doing reconciliation. Okay. Export Java underscore, because I want to run the Presto client now. Java underscore home. Again. Java underscore home.
I found 15 places. Click the one you...
/home /Cloudera /MongoDB /JDK 1. 5 times I did in front of you now. How to set Java home. Okay. Now please don't make a mistake in life. Okay. Export path equal to $Java underscore home / when you press tab, you should get that remaining thing. That means it is correct. /bin and $path. Now cd Presto server. Java minus version 1.8 point. Correct. ls CLI, clear. Java minus jar presto CLI, and the prompt will come. Once the prompt is coming, select star from Kafka dot realtime dot test. See, SQL. That's your complete data. And wait. If you want to see the messages, select underscore message from Kafka dot realtime dot test. SQL, Flume, whatever you like now. So do the real-time analytics now. From the event bus it is coming, and you just take it, combine it with your Hive, combine with your Oracle, reconciliation, whatever you want to do, everything.
So, the how do we connect the JDBC connection here?
Which one? To Oracle?
Can we connect to JDBC here?
Of course.
Yeah,
MySQL is there. Okay. Now let us see some more fun that is clear. Right. Hive is there. Right. Hive is already there. Do we have the Hive properties? Control D. Wait a minute. Wait a minute. Where is that? CD etc / catalog. Okay. Inside the catalog, we should have what? Hive dot properties. Hive Hadoop to localhost 9083. I'm not sure whether this will be working or not, because that localhost will create a problem. Okay, anyway, let me try that one. Okay, so what I'm going to do is, anyway, MySQL is working, right? So select star, or sorry, show, we have to start the this one, Presto server, this one, Java minus jar. And now what we are going to do is show catalogs. And you should have MySQL, Kafka and all. And now show tables from MySQL. Okay. Show tables from MySQL. Show tables from MySQL dot retail db dot retail underscore db a, and then press enter. No, my retail underscore db. So what is the name of the catalog? MySQL retail underscore db, I think. Okay, you got all your favorite tables. 6 tables are there. Now I want to join Kafka with MySQL, and then I want to write the result into Hive. How will you do that? Create table Hive dot default dot sample. Okay, Hive dot default dot passion. Provided the Hive is not working, I'm not guaranteeing that. As select star from Kafka dot realtime dot test, comma MySQL dot, just I am writing it. You can write an inner join, whatever you want. MySQL dot retail underscore db dot departments.
Can you export these details?
Anything that you want.
So where did you give these property files?
Wow! Table created in Hive by joining the data from multiple data sources. Now select star from Hive dot default dot. What do you need more than this? This is the maximum possibility of current big data world. Nothing more than this. Seamlessly accessing the whole technologies, real time versus Hive versus Hadoop versus big data versus databases. What is there? Nothing.